Okay, any doubt from the last class? So in last class, we were discussing about Cauchy-Euler equation. In fact, it is an equation which can be solved on the similar line uh, uh, of like solving a constant coefficient differential equation. So here, equation is something like x square d2y by dx square plus alpha x dy by dx plus beta y equal to 0 here. Uh, it may be Rx also. Let me write it Rx and then you start. It is Rx here. So here, this alpha and beta are constant, and Rx is a continuous function. Right. So this is a Cauchy-Euler equation of second order. And to solve this in a similar line, we have tried uh, when Rx is not equal to 0, we call homogeneous, and when Rx is non-zero, we call it non-homogeneous. Non-homogeneous. And we are trying to solve first the homogeneous and then we'll solve Cauchy, non-homogeneous problem. So we're discussing about homogeneous Cauchy-Euler equation. So here I'm uh, assuming that x is greater than 0 and we are solving x square d2y by dx square plus alpha x dy by dx plus beta y equal to 0. And we have seen that if we take yx equal to x to power r, say m, then we can write it here. If we call this as ly equal to this, then we can put l x to power m as following. We can write it here m into m minus 1 uh, uh, plus alpha m plus beta into x to power m, right? So LXM is equal to this. So it means that XM is a solution if LXM is equal to 0, or you can say that M minus 1 plus alpha M plus beta into x to power m is equal to 0. So here we say that x to power m is non-zero because x is greater than 0. So only possibility that this x to power m is a solution here if m into m minus 1 plus alpha m plus beta is equal to 0, which we call this as auxiliary equation. So this we have already done. Okay, auxiliary equation. Or sometimes we also call it initial equation. Okay. So once we have initial equation, then it is a quadratic equation in terms of m, right? So if you can simplify, it is m square plus alpha minus 1 m plus beta equal to 0. Then we have three possibility. Case 1, in fact, you can find m equal to uh, uh, alpha minus 1, right? Minus of alpha minus 1 plus minus b, b square means alpha minus 1 whole square minus 4 beta upon 2. So here everything depend on this discriminant, which is alpha minus 1 whole square minus 4 beta. So case 1, when alpha minus 1 whole square minus 4 beta is greater than 0. So in this case, we have roots are real and distinct, right? So if roots are real and distinct, then solutions are y1x equal to x to power m1. Let us call it, let us say, let us say m1 and m2. So we can write x y1x is equal to x to power m1, and y2x equal to x to the power m2. And we have seen one example of this also in the last class. Now, case 2, when alpha minus 1 whole square minus 4 beta is equal to 0. So in this case, we have equal root, right? And we can say that I will get m1 equal to m2 equal to 1 minus alpha by 2. Is it okay here? This is not a problem here, that we are getting only one solution, and we say that y1x is equal to x to the power 1 minus alpha by 2 is one of the solution. And how to find y2x? To find out y2x, I think you already have one relation, right? Using one solution, how to find out the other solution. Okay, so how to say that? You simply say that it is ux into y1x, and ux is a function which you have to find out such that this y2x also satisfy this equation x square y double dash plus x alpha x y dash plus beta y equal to 0. So assuming that y2x is a solution of this, find out ux. Is it okay? So in this case, you can find out the other solution using this. Is it okay? Is there any problem?
So,
Yes.
so is it necessary that y2 and y1 are linearly independent? Like if we write y2 in this form?
Yes. Why it is why it is linearly independent? Because this ux is a function, right? So you simply write it here.
Is it possible
Yes.
that we, when we solve the differential equation, we get a form of ux such that it is a constant?
Uh, 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 Please repeat what you are saying.
So, like, is it possible, like, when we solve the differential equation for y2, then ux has a form such as a constant or something like that, and y2 and y1 become linearly dependent?
No, I'm saying that if you have a solution like y1x and you multiply by any constant, it will always a solution, right? In fact, you consider a simple differential equation, right? And if you have y1x is a solution, right? Then c1 c into y1x is also a solution. I'm not denying this fact. If
No,
y1x
no, sir. I'm
is a
saying like
solution, uh,
I'm saying that
yeah,
when we write y2 is equal to ux into y1x, does that guarantee
yes,
that y1 and y2 are linearly independent?
yes. Why it is so? Let me tell you that we have seen that if we have two solution y1x and y2 function, let us say, let y1x and y2x be two function of x, right? Function of x. So when in what case this can be linearly dependent? If we have c1 y1x plus c2 y2x equal to 0, and at least one of them is non-zero. Yes, in that case only y1 and y2 are linearly dependent. Is there any other definition we know then?
So I've got this definition
Yes,
that you have said
yes,
that
yes,
like if I want
yes,
y2
yes.
related by some function of ux, then they are not linearly dependent. So I'm saying that when we solve for y2, is it possible that
Uh-huh.
we get ux as some constant, or it is necessary that ux will be some function of x, like we have presumed?
Okay. So here, I'm still not getting what is your question. Uh, I think Abul Fazal, just one thing. First, if y1x is a solution, then constant multiple is also a solution. The only problem is that it is not linearly independent. Like y1x and cy1x are linearly dependent, right? Now our work is what? Our work is to find out two linearly independent in case of second order differential equation. Now, how to find out two linearly independent solution? So what we have tried, since it is linearly independent, so it means that the ratio of y1 and y2 cannot be a constant, right? So it means that if y2 exists, right, as a linearly independent function to y1, the ratio has to be a function of x, right? Now, what is that function which we don't know? So here, first thing which we assume that this y2x since y2x is a linearly dependent to y1x, so I have to assume y2x as some multiplication of function into y1x. Right now, it make y2x and y1x are linearly independent, but still we are not sure whether this y2x is a solution of differential equation or not. Then you have to put a condition on ux such that this y2x become a solution of the second order differential equation. Right now, uh, now look at the from the equation side. Now suppose you have an equation given to you. All right. Now, since it is a second order equation, and we already proved that if it is a second order differential equation, then we must have two linearly independent solution. Right. This we have proved as this we have proved it or not, that if we have a second order differential
Yes, sir.
equation, then we have two linearly independent solution. Right. Now, if we have two linearly independent solution and we got one solution, that is y1x. Right now, if we want to find out y2x, then since it is linearly independent, it cannot be a constant multiple of the first one. Are you getting my point?
Yes, I got it, sir.
Still, if you have any doubt, you can separately call me and we can discuss over it. I
No,
think
sir, I
still
got.
you have confusion because you
No, sir,
got
I got it,
the
sir.
same question. Okay, okay, fine, thank you. So, okay, so here I'm stopping here. So I'm saying that uh, assuming that y2x is equal to ux y1x, you can find out, you can put it back to this equation and find out the value of ux, right? And in that way, you can find out the second solution. But here in this case, we have another method to find out the second differential equation. For example, if you look at here, we have this equation x square y double dash x plus alpha x y dash x plus beta yx equal to 0, which I am writing as L of y equal to 0. So here basically Ly is equal to 0 and operator form. Now when we write L of x to power r, then it is what? It is simply you are getting like r into r minus 1. Oh, sorry, m into if it is x to power r, then it is let me write it m so that there is no confusion. X to power m, then you will get m into m minus 1 plus alpha m plus beta into x to power m, right? So L of x to power m is equal to this. Now, in this case, when m has two equal root, it means that we are getting this, that m minus m1 whole square uh, x to power, right? So it means that L of x to power m, I'm getting like this. Is it okay here? So there is no problem, right? So now here, if I say that this is a kind of a equation or identity in terms of m, you treat m as a variable here. Now, if we treat this m as a variable, then I can differentiate with respect to m here, and we can differentiate with respect to m. Why I'm writing partial derivative? Because we already know that x is a variable. So when we differentiate LXM with respect to m, you will get what? 2m minus m1 x to power m plus m minus m1 whole square x to power m ln x. Now, I have already assumed that x is greater than 0, so ln x is properly defined here. Is that okay? And now here, L is a operator like this. Then we can take the derivative with respect to m inside also, right? So we can write here L, we can write x to power m ln x is equal to 2m minus m1 x to power m plus m minus m1 whole square x to power m ln x. Is it okay? Is there any problem here? No?
No,
Okay. Now I'm claiming that now if I choose m equal to m1 in this equation, so this is kind of an identity in terms of one, in terms of m. Now if I choose m equal to m1, the right hand side will be what? It is simply 0, right?
0.
So it means that L of x to power m1 ln x will give you 0. It means what? It means that this x to power m1 ln x is a solution of L of y equal to 0. How we define solution?
Yes, sir.
We define solution, the value of y such that L of y is equal to 0. So it means that x to power m1 ln x is also a solution. So in this case, your solution, I will write here yx equal to c1 x to power m1 plus c2 x to power m1 ln x. Right? So in this case, your second solution can be obtained like this. You can verify that if we use this method, then solution will also come in this one. So let us take one example here. So it means that one solution you can obtain like x to power m1. Another solution you can obtain by differentiating x to power m uh, uh, with respect to m evaluated at m equal to m1. So we can say your y2x is equal to double by double m of x to power m evaluated at m equal to m1. Is it okay? Now you find out one example solution. You have find the general solution of x square y double dash minus 5x y dash plus 9 y equal to 0. Just can you find out the solution here? What is y of x here, or ycx? C1 plus C2. Yeah, tell me what is y1 and y2. One more thing I want to tell you, that now I'm collecting all the attendance because I'm not very happy at looking at the attendance. So I'm just collecting all the attendance. Maybe it is useful later on. I'll just find out y1 and y2.
So x cube and x cube ln x.
X cube and
And
x
x cube
cube
ln x.
ln x. Okay, fine. So it is okay here. Now case 3. So here alpha minus 1 whole square minus 4 beta is less than 0. So in this case, your M1 and M2 you are getting as um, because alpha beta I'm already using A plus IB and A minus IB. Oh, IB. Okay. A plus IB, A minus IB. Then, so we'll get solutions since A plus IB and A minus B are distinct. So it means that we are getting a YCX as C1 x to power A plus IB plus C2 x to power A minus IB. How to define x to power A plus IB we have already discussed. The only thing is that x to power A plus IB is written as x to power A cos of ln B plus I sine ln. Right. So it is the form of the solution given in complex form. Right. So we can simplify and we can say that once we have a complex solution, then its real part and imaginary part are also solution of the differential equation. I think this we have already proved here. So it means that I can find out the real solution y1x equal to x to power a cos of ln b and y2x as x to power a sine of ln b. Right. So this implies that your ycx can be written as c1 x to power a cos of ln b plus C2 sine of ln b, x to power a sine of ln b. Is it okay here? Is it
Yes.
okay? There's a small problem here, I think.
Yes, sir. How
Uh,
cos LNB and without the cos of
yeah,
x?
yeah, yeah, yeah. So here there is a problem in writing this part. So this I'm writing as x to power a, and x to power ib I'm writing as x to power a e to power ib ln x. So here, yeah. So there is a doubt and there is a problem here. So it is b ln x, not ln b. Huh? So a small mistake. So it is basically b ln x. B ln x. Okay. So it is okay now, YCX. So this is the general solution in case of complex roots here. So example, I think, okay, so let us say x square y double dash minus 5x y dash plus 25y equal to 0. Yeah, just find out your y1 and y2. Write down YCX. So what are the roots and then what is initial equation? Initial equation, find out initial equation like m into m minus 1 plus alpha m. Alpha is minus 5, so minus 5m plus 25 equal to 0. So we solve this m square minus m minus 5m plus 25 equal to 0. So m square minus 6m plus 25 equal to 0. So m equal to 6 plus minus 36 minus 100, right? Upon 2. So it is like 6 plus minus 64. So 8i, right? Uh, okay. So it is 2 and it is 64 minus 64. So it is 3 plus minus. Um, so it is basically 8. So 4i, right? So m is so m1 equal to 3 plus 4i and m2 equal to 3 minus 4i. So your solution, I can write it here, ycx equal to x cube cos of 4 ln x c1 plus c2 x cube sine of 4 ln x. Is it okay here? I can write it like solution like this. Okay. Then, if you have no doubt, I will move ahead. Is it okay here?
Yes, sir.
Yes, sir.
Now, since so far I have assumed that x, so far we have assumed that x is greater than 0. Now, but what happened when x is less than 0, right? So let us say that you simply write that, let us say x equal to minus t and t is greater than 0, right? So it means that here I'm considering the case when x is less than 0. Then I'm assuming x equal to minus t. In that case, t is greater than 0. Is it okay? Then I just want to find out what is dy by dt. So dy by dt equal to dy by dx and dx by dt here. This I can write it, yes or no? We simply chain rule I can apply. So here, yeah. So it is minus dy by, I think I have to write dy by dx, not this. Okay, yeah. Anyway, I can find it here also. Okay, fine. So here I will write dy by dx, and what is dx by dt? It is minus. So I can say that your dy by dx is equal to minus dy by dt. First thing is this. Now, can you find out d2y by dx square? So it is nothing but d by dx of dy by dx, which I am writing as d by dx of minus dy by dt. which I am writing as d by dt of minus dy by dt and dt by dx. So it is minus d2y by dt square, and dt by dx is something which is known as minus 1, right? So minus and minus, this will come plus. So d2y by dx square become plus d2y by dt square. Is it okay? So it means that I can write here the same equation in terms of new variable, that is t. So I can write d2y by dx square, x square here, plus alpha x dy by dx plus beta y of x equal to 0. Now I'm just changing the independent variable. Now in place of x, I'm writing t here. So we can write it here, x equal to minus t. So it is simply uh, minus t whole square d2y by dx square is equal to d2y by dt square plus alpha x is minus t and dy by dx is equal to minus dy by dt plus beta y of t is equal to 0. So I can write this as t square d2y by dt square plus alpha t dy by dt plus beta yt is equal to 0. So it means that the equation, when I'm assuming that x is less than 0, so the Cauchy-Euler equation, this with x is less than 0 can be written as, rewritten as where s t is greater than 0. Yes, so in this case, your solution, I can find out solution as y of t. I can write here, depending on the form, I can write it here c1 t to the power r1 plus c2 t to the power r2 when we have distinct solution, and when we have c1 t to the power r plus c2 t to the power r ln t, or I can write c1 t to the power alpha or t to the power a uh, cos of b ln t plus c2 t to the power a cos of b sin of b ln t, right? So depending on this, I can also find out a solution like this. Yes or no? So now here, if you want to write in terms of minus t, right? So here, what is t here? T is minus x, right? And the same solution I can write when x is positive. So in place of this, I'm assuming that in all cases, x square y double dash plus x alpha x y dash plus beta y x equal to 0. When x is not equal to 0, the solution I can write it here that c1 mod of x to power r1 plus c2 mod of x to power r2 and c1 mod of x to power r plus c2 mod of x to power r ln uh, x and c1 x to power a mod of x to power a cos of b ln mod of x plus c2 x mod of x to power a sin of b ln mod of x. The reason is that if x is greater than 0, then this mod x become x, right? And this will represent the first case when x is greater than 0, right? But when x is less than 0, then this mod of x become minus x, which I am writing as t. Then this solution will represent this one solution, this solution. It means that when I can solve the Cauchy-Euler equation for x not equal to 0, and solution can be written like this. Is it understood by all of you? That when x is negative, I can change the variable, independent variable, and I can write this differential equation in terms of a new variable when t is greater than 0. So I can solve this Cauchy-Euler equation in terms of t like this. So if we combine both the solution, then I can write down the solution, and this solution is valid for all x other than 0. Now, if you have any doubt, you can ask. Otherwise, I will move ahead. Yes? Fine? Yes or no?
Fine, sir.
Okay. So once now this means that this Cauchy-Euler equation we have uh, discussed. Now here we simply say the idea of solving Cauchy-Euler equation and the equation with constant coefficients are almost same. There we solve our equation as we assume e to power mx is a solution, and here we are assuming x to power m as a solution here. So by the way, x to power m, how I can write it? X to power m, this I can write it here as e to power m ln x. Is it okay? I will tell you why I'm writing this. So please remember this, that why I'm writing this. Anyway, so this I will discuss later. I will discuss later. This is very important thing. Okay. So now coming to the variation of parameter method. So now let us say that we have y double dash plus p y dash plus q y equal to rx, right? And yc is given, yc equal to c1 y1x plus c2 y2x is given, and want to find, say, yp here. So as I said that if this c1 and c2 remain constant, then this c1 by 1x plus c2 by 2x will give you the general solution of the homogeneous problem, right? Now here we are claiming that if c1 and c2 are function of x, then c1x y1x and c2 y2x, c2x y2x will not represent yc, right? Now our thinking is that what happened that if I assume that c1x y1x plus c2x y2x, is there any possibility that we can choose two functions c1x and c2x such that this c1x y1x plus c2x y2x uh, uh, become particular solution? So we have to choose that such a possibility exists or not, particular solution. So can we find c1x and c2x such that this c1x y1x plus c2x y2x become particular solution? So we have to see whether this such a c1 and c2 exists or not. Okay. So for that, I have to check whether this actually satisfies this differential equation or not, under what condition it will satisfy that. So we find out yp dash. It is like c1 x y1 dash x plus c1 dash x y1 x plus c2 x y2 dash x plus c2 dash y2 x. So if it is clear to all of you, I'm just writing as c1 y1 dash c1 dash y1. So I'm just writing this as c1 y1 dash plus c1 dash y1 plus c2 y2 dash plus c2 dash y2. I'm just writing it. Okay, so yp dash is this. Now we look at yp double dash. So it is what? c1 y1 double dash plus c1 dash y1 dash plus c1 double dash y1 plus c1 dash y1 dash plus c2 dash y2 dash plus c2 y2 double dash plus c2 dash double dash y2 plus c2 dash y2 dash. Or if we want to rearrange, we can rearrange also. But the problem is that we are trying this method to solve a second order differential equation. In fact, we want to find out a particular solution of second order differential equation, right? So here, we if we find out yp double dash like this, right, then we are landing up in solving a differential equation we have where we have double derivative of c1 double dash, c1 and c2 double dash. So to avoid this, since we have two functions, so I can choose two conditions, right? So what we try to do here, that we choose two condition on C1 and C2 such that we can get a solution. So first condition which we are writing here, that this double derivative is coming because we have first derivative in the yp dash. So here it means that if I assume that C1 dash y1 plus C2 dash y2 is equal to 0, right? So if it is 0, then what you will get? Then I will not get any term because of this thing. So it means that what we are not getting here, we are not getting these terms. These terms will not be there here, right? And these terms will simply vanish. Yes or no? Are you getting this point?
Yes, sir.
So idea is just to avoid second order derivative in terms of a known function, we can assume certain things. So since right now we have to obtain two unknown solutions, so it means that we can find out two unknown function in a unique manner if we have two condition associated with C1 and C2. So first condition which we have assumed is that the C1 dash y1 plus C2 dash y2, we are assuming that it is 0 here. So if it is 0, then this term will not be there and this term will not be there, and we'll get yp double dash as C1 y1 double dash plus C1 dash y1 dash plus C2 dash y2 dash plus C2 y2 double dash, right? So here we don't have any second order derivative because of this thing. Is it okay? Is it clear here? Okay. So now I'm assuming that this is a solution of our equation, that is y double dash plus p y dash plus q y equal to rx. So can you put it back here? So here I'm writing here y double dash, I'm writing here is this. So c1 y1 double dash y1 double dash plus okay, c1 dash y1 dash plus c2 dash y2 dash plus c2 y2 double dash plus p times I'm assuming here c1 y1 dash plus c2 y2 dash, because this part is simply vanish, plus q time now y I'm writing here as c1 y1 plus c2 y2, and this is equal to r of x. Is it okay here? Now just collect y1 dash y1 component and y2 component separately. So let me write it here. C1 y1 double dash plus what I will get here, C1 p y1 dash. This I'm writing, and this I'm writing, and this I'm writing. So it is C1 q y1 plus. Now I'm writing here this term, this, this, and this. So writing here C2 y2 double dash plus C2 p y2 dash plus C2 q y2. And what is left here? What is left here is the following. So this is left, and this is the only thing left. C1 dash y1 dash plus C2 dash y2 dash is equal to r of x. So what is the benefit in writing in this way? Anybody?
So the above two terms is 0.
Yeah, because y1 and y2 are solution of the homogeneous problem. So this part is equal to 0 and this part is equal to 0. So what you will get here is the following thing, that c1 dash y1 dash plus c2 dash y2 dash is equal to r of x. So this is another condition which you have obtained. One condition you have obtained like this, call it 1. So here we have one condition, that c1 dash y1 plus c2 dash y2 is equal to 0, right? This is condition 1. So it means that now we have two conditions in terms of c1 and c2 here. So what are those conditions? First thing is c1 dash y1 plus c2 dash y2 is equal to 0. Another one is c1 dash y1 dash plus c2 dash y2 dash is equal to rx. Or I can write it here as the following. Let us say y1 y2 y1 dash y2 dash c1 dash c2 dash is equal to 0 and r of x. So this is a kind of a algebraic equation. Right now I cannot say it is algebraic, but it is a equation which is written as ax equal to b kind of a format. So from this we wanted to find out the value of c1 dash and c2 dash. So what is the value of c1 dash x here? Anybody? Have you done Cramer's rule? Yes. Have you done Cramer's rule?
Yes, sir.
Okay. So can you find out c1 dash x? What is in numerator? This is a determinant of this coefficient, and in numerator you will have 0 rx y1x y2x and y2 dashes. Is it correct? Am I correct here?
Yes, sir.
Okay. Similarly, c2 dash x now. How I make sure that denominator is not vanishing? Yeah. So how I can make sure the denominator is not vanishing? Yeah. This is I can write
So
minus rx y2. Yeah.
if we know that y1 and y2 are solution, then their Li and Wronskian is non-zero.
Here I have to say one thing. Y1 and y2 are solution that need not to be linearly independent. What we know that y1 and y2 are two linearly independent solution because they are forming the general solution of the homogeneous part. So here, when I write yc equal to, when I write this, so it means that I'm assuming that y1 and y2 are linearly independent, right? And in that case, this denominator is nothing but the Wronskian of y1 and y2. And we already know that if y1 and y2 are linearly independent, what happened? Why this number is suddenly very less? Is there any quiz or something else?
No, sir. The attendee, they are in the attendee's position.
Uh, so how come? Who is changing basically?
Someone is removing from the meeting.
Someone is removing everyone.
Yeah.
Who is removing?
We
Please tell
don't.
So
me.
that I don't know.
Okay. Because suddenly I realized that there is a small change. I'm not able to understand. Someone is taking care of me. Huh? I don't know. Because I think it is not needed here, right? Anybody can present, anybody can attend. Anyway, the problem is that if somebody want to remove one person, then there is a problem. Anyway, so all the people are here, then that's good. Okay, so let me show you. So the denominator is nothing but the Wronskian of y1 and y2 of x, and we already know that this is non-zero because y1 and y2 are linearly independent. In the same way, c2 and dash x can be written as rx y1x divided by Wronskian of y1 and y2x. Is it okay? So it means that I can find out c1x by integrating minus rx by 2x divided by Wronskian of y1 by 2x dx, and c2x I can write integration of rx y1x Wronskian of y1 and y2 x dx. So once you got c1x and c2x, then yx is equal to c1x y1x plus c2x and y2x becomes particular solution of y double dash plus p y dash plus q y equal to r of x. One more thing which I want to tell you here, that we have not assumed anything here, whether this p and q are function of x or p or q are constant. What we have assumed here, that we already have solution of the homogeneous problem. Yes or no? So if you already know the solution of homogeneous problem, whether this p and q are function of x or not function of x, we don't care. So only thing is, once we have solution of the homogeneous problem, we can find out the solution of non-homogeneous problem by finding C1 and C2 like this and putting it back, and we can get particular solution like this. Is it okay here? So let us take one example and then we try to understand it in a different way. So before that, if you have any doubt, you can simply see.
Sir,
If
can
you
we do
have
the
any doubt, you
vice?
can show it. Yeah.
Sir, can we do the reverse way? Like if we have the particular solution which to our Li, so can we find the uh, homogeneous solution using this only?
If you have two particular solution, then you can simply find the difference and it will be a solution of homogeneous problem. From one, you cannot find it. Are you getting my point? And please try to
Yes, yes.
understand, when we try to solve a harder problem with the solution of the simpler problem, right? So finding the solution of the homogeneous problem is a little bit easy, but solving a solution of the non-homogeneous problem is a little bit difficult. Right? So we try to find out a solution of a difficult problem, that is solution of non-homogeneous problem, with the help of solution of homogeneous problem, which is a relatively easy. Are you getting my point?
Yes, sir.
Okay. So let us take one.
Hello.
Mohak,
Yes, sir. Can
Mohak,
you?
want?
Yes, sir. Am I audible?
Yeah, perfect.
Yes, sir. I wanted to see that above condition where we said that y1 and y2 are Li.
Yes. Tell me. Then
Means yes. Then we said that its Wronskian would be 0. Yeah, yes, sir. YC. We assumed it, didn't we?
yes, when we write YC, it means that we are writing a general solution of the homogeneous problem. And general solution of the homogeneous problem can be written only when we have two linearly independent solution of the homogeneous problem are available to us. So it means that we are already assuming that y1 and y2 are linearly independent solution of the homogeneous problem.
Okay, sir. I got it.
Okay. So here, when we write YC, it means that y1, y2 are linearly independent already. Okay, so let me give you one small example. So I will give you two different example. Let us say y double dash plus y equal to 10 of x. So just find out the solution, and interval I'm giving you minus pi by 2 to pi by 2, because in this reason your 10x is continuous function. So can you find out the solution here? So I think YCX, yeah, what is YCX here? So YCX is basically general solution of the homogeneous problem. So what is homogeneous problem? Homogeneous problem is y double dash plus y equal to 0. So can you find out two linearly independent solution of this y double dash and y plus y equal to 0? Yes.
So I think it will be complex. Like, if we assume e raised to mx, then m will be plus minus
Yeah.
I.
Do it. You just tell me. It is a complex. Yeah, fine. But I want
So cos
to
x,
find out two real.
sin
Yes.
x.
Yeah. So you'll get c1x cos of x plus c2x. Sorry, not c1x, c2x. C1 cos of x and C2 sin of x. Okay. Then what is the Wronskian of y1 and y2? So it is y1, y2, y1 dash, y2 dash. So can you calculate what is this? It is cos of x, sin of x, minus sin of x, and cos of x. What is this value? Yes?
So 1.
1. Okay. So Wronskian you got. So C1x will be what? C1x we have obtained minus r of x, y2x, divided by Wronskian of y1, y2, x. So here this is your y1 and this is your y2, d of x. Right? So Wronskian is 1, so I can write rx is basically 10 of x. So 10 of x, y2x is sin of x, d of x. So you have to calculate this. C2x is basically r of x, y1x, Wronskian of y1 and y2. So you just remember this formula, C1, and then you have Y2 here. If it is C2, then we have Y1 here. In C1, there is a minus sign, and C2, there is no minus sign, right? So just calculate here. It is simply 10 of x, cos of x, and this one, d of x. So can you just calculate this C1 and C2 here?
C2 will be minus sin x, minus cos x.
C2 is minus
Minus-
cos x. It is minus cos of x. Very good. What about C1x? C2 is quite easy to, because it is coming out to be integration of sin x. Very good, very good. Thank you.
So it will be ln cosec x cot x or so.
Yeah, please tell me what is u1x? Yeah,
So I think it will be integration of sec x, and like you can split the above sine square x term into 1 minus cos square x upon cos x. It will be integral of cos of x, which is minus which is sine of x, and minus integration of sec of x.
What?
Minus
Then
integration of sec of x.
so what is that?
I don't.
Okay, I also don't remember,
Sir,
but
log
I
sec
remember
minus
this.
tan.
Log
Yeah.
secant x minus tan x.
Minus or plus? I don't know.
Mine.
You just see whether it is plus or minus. You just write it. So you got C1x and C2x, and then we can write ypx equal to C1x, that is sine of x, minus ln. This you have to make it confirm whether it is mod of sec x minus tan x or plus
Sir, it
next?
is plus.
Oh, okay, it is plus then. Okay, thank you. Into y1. So what y1 is basically cos of x plus y2 c2 that is minus cos of x into sin of x. So you can calculate, and what you will get here. So this will be cancelled out here. So I will get here as minus cos of x ln of sec of x plus 10 of x. So x. Is it okay here?
Yes.
Okay. Now I'm giving you another example. In that example, your constant coefficients are not there. It is a simply let us say Cauchy-Euler equation. Okay. So let me write it here. So we have x square y double dash plus x y dash minus y equal to x square e to power x. Right? So is it okay? So can you do it? So first you have to find out ycx. Yeah, what is yc here?
So x to the power 1 and x to the power minus 1.
X to power 1 c1 x plus c2
1
1 by
upon
x.
x.
Right? So now here, please write down here that when we discuss this problem, we have assumed that the coefficient of y double dash is 1. When we discuss this entire procedure, what we have assumed, you assume is that y double dash plus beta y dash plus qy equal to rx. So coefficient of y double dash is equal to 1. This is very common mistake which many of us will do. So we simply apply the formula directly. So but here you should not directly apply the formula. So here you rewrite this as y double dash plus 1 by x y dash minus 1 upon x square y equal to rx is now e to power x. So this is the way problem where we are getting confused. So here rx is e to power x, not this x square into e to power x. Are you getting my point? So this is a common mistake which we generally do. So Wronskian of y1 and y2, it is y1, y2, y1 dash, y2 dash. So can you find out what is this? It is x, 1 by x. It is 1 minus 1 by x square. Just calculate what is this?
Minus 2 by x.
Minus 2 by x. Very good. So it is minus 2 by x. So can you calculate c1x? C1x is equal to minus rx y2x divided by Wronskian of y1 and y2. So please make a habit to write down the formula first, and then so Rx is e to power x, y2x is basically 1 by x, and Wronskian is minus 2 by x. Okay. So you calculate it. Similarly, C2x is equal to Rx, that is e to power x, into y1x, which is x here, and then minus 2 by x. So can you calculate this C1x and C2x? So I believe that you can do it.
Yes.
And if you have any doubt, you can ask. Otherwise, we'll leave this class. We'll close this class. So those who are having something to discuss may stay. Otherwise, they may leave. You complete this C1 and C2 and complete this problem. If you have any doubt, ask. Otherwise, I will leave. Okay. So no problem. Closing.